All right, so let's go ahead and talk about some of the biggest hurdles we typically get in programming, which is for loops. All right, the idea here is that at the end of the day, we're very lazy people, and we like to repeat stuff a whole lot. Suppose I write something. So let's first off start off by introducing there's a couple different commands for printing, right? We know how to print out something using system.println, right? If I do hello, and then I do system.println, if I do println world, then it's going to print on one line hello, and then on the next line it's going to print world, right? First line, so println prints hello, then starts a new line, and then prints world, and then starts a new line. There's a second command in Java that's a lot like println, but we missed 2 characters from it. Instead, we have system.print, and the difference is pretty apparent here. What happens? So if we run it, it says hello world, all one word, and then process finished with exit code 0. So what print does, it prints out the characters it prints out the string that you tell it, but it doesn't put a new line in between each of them, right? So println prints out. So here I'll do. Let me mix it up a bit. Println hello. So let's see. So we'll do an exclamation point here with a print. So I'm interweaving a print and a print line. Star. And okay. So first print hello. So we print out the strings hello. Then println world. So we print out world and then we do a new line. Print exclamation point. Then we print a line exclamation point, which means we print out another exclamation point, and then we go on to the next line. And then we print out done. And then we don't print out a new line. Okay? Now, we typically do not mix like the interweave stuff like this. We typically don't do that. That's typically just done to mess with you on a quiz question or something like that. But I probably won't do anything like that. But it's useful to know that you can basically print out a bit of a line, then you can print out a bit of the line, and then you can print out a bit more of a line, and then you can go to a new line after that, right? So you can add to a bit of a line. So let's just go ahead and keep this for reference in a different method, right? And we learned how to write a different method. So let's create a new method, public static void print interwoven, right? And that basically creates a new command in Java. So I'm going to go ahead and take these things over here and move them into here. And now if I want to use it again, all I have to do is use the command print interwoven, and it will print it. In fact, I can call it multiple times, right? We can just have a new command that's just lying there. Okay, so that's just the stuff that I need to get out of the way before we can start talking about for loops. So now for loops so we've learned about basically let's make decisions. Let's do this if this is true. Otherwise, we're going to do that if this is true, right? Sorry, if it's not true. So if one thing is true, we do this. If it's not true, we do that. Okay. So for the for loop, that allows us to repeat. So that's conditional statements. So the for loop is our iterative statement. It is what we call a determinate loop. It repeats an action a predetermined number of times. And the format always looks like this, which is a little bit weird. But the main thing to remember is that we start from 0. So for, and it looks like this. I'm going to actually go ahead and I think the text is a little small. People want me to increase the text size back there. Yeah, okay. So let's go ahead. Settings, editor, font. So let's bump it up to 20. Sure. 20. Much better? Okay. So a for loop looks like this. For int I equals 0. So this is kind of what we call a kata. If any of you have done martial arts, that's kind of like a form, right? This is like the form that basically that you write to do a for loop. For int I equal to 0. I is less than, let's say 5, I plus plus. This is all a bunch of gibberish. Don't worry about the gibberish first, but it will become apparent but some experimentation will make it apparent without even having to understand a single bit of what's going on. So I'm going to print bang. So some experimentation before we actually like analyze it will help us know what's going on. Okay, so print line. Okay, so let's go ahead and run this. Whoops. So there we go. So for int I is equal to 0, I is less than 5, I plus plus, system.out.print bang. So I ran it, and how many exclamation points did it print out? 5, right? Okay. So let's change this. I'm gonna do 3 here. Okay, I'm gonna run. So I changed this from 5 to 3. How many exclamation points just printed out? 3. Okay. Okay, let's go ahead and change this to 2. It's 2. How many exclamation points are going to print out?
90.
90, exactly. Right? It's going to print out 90 exclamation points all on the same line. I'm not going to bother counting them. I think that looks like 90, though. Actually, you'd think it would look longer, right?
Yeah. Doesn't look like 90.
Yeah. It's a.
I give up. I'm not going that.
All right. The point is that once you get like above 7, it becomes really hard to count things just at a glance. So if we see something in this format where it says I is 0, I is less than 100, I plus plus, this format basically tells you this is going to run whatever number's here by the less than sign. That's the number of times it's going to run. So if I put 1,000 here, right, there's 1,000 exclamation points. Okay? Goes in tight. So the
If you need me to step up, I'll be really good.
So the last, so the for loop has 3 parts, okay, that each separated by these by the semicolons, and they're not too hard, okay, to basically analyze. So I'm going to put a comment above and label each of the parts. Initialization. I'm going to just use spaces to separate these things, right? Initialization. Loop condition. Your book might call it something else. And the post operation, which also might be called something else. Not really sure what your book calls it. Let's see if it goes into detail about what it decides to call these things. Because I've heard it called, believe it or not, different things by different people. So I'm skipping over chapter 6 for right now because I wanted to get into here, and I've actually started in the middle of chapter 6 because I like going in reverse. Started in the middle of chapter 7 because I like going in reverse. So the for statement has, so they call it the initializer, the update, and the condition and the update. Okay. So initialization, the loop condition, and the post operation, which they call the update. Okay. So the first thing is that basically when we start a loop, the first thing that runs, when we declare this loop, the first thing that happens is the initialization. So this declares a variable that exists inside the loop and only inside this loop. So it only exists for as long as the loop exists. Once we're done with the loop, the variable I will no longer exist. So initialization, anything that you want to initialize goes here. So typically what we do is that we put like something like int I is equal to 0, which acts as like a counter. Okay. The loop condition, the loop will run so long as this is true at the beginning of the loop, of each iteration of the loop, this will run. So we start at 0, I is less than 1,000, so the loop is going to run. The post operation happens at the end of every iteration of the loop. So once we get to the end of each part of the loop, it will increment I to it will run this, which increments I by 1. So let's go ahead and add some commentary into this. Okay? System.out.println, and I'm going to change these to print lines. So print line I is plus 0. I is, well, the value of I. Got the print line. Okay, so let's go ahead and run this now. So we start out with int I is equal to 0. So let's check our loop condition to see if it's going to run. Is 0 less than 5? Yes, it is. Okay, so we print out I is 0. Then we print out exclamation point. Then we run this code. Loop code has ended. Running update. So once that has run, we do I++, which updates I's value by how much? 1. So now I's value, now we run this code again. I is 1. Is 1 less than 5? Yes, it is. So we print out I is 1, exclamation point, loop code has ended, running update. So we increment it to 2. Is 2 less than 5? Yes, it is. So we keep running, so we run the code again. 2 is less than 5, so we print out I is 2, exclamation point, loop code ended, running update. So now we increment it again. I is now 3. Is 3 less than 5? Yes, it is. And so we run this again, and then update it to 4. Is 4 less than 5? Yes, it is. So we print out I is 4, exclamation point, loop code has ended, running update. So now we increment it to 5, and now we ask ourselves, so we printed out the values 0, 1, 2, 3, and 4. Now we're at 5. Now we have to ask ourselves, is 5 less than 5? Nope. So we stop. So now the code is done, and we've stopped. So now as soon as this turn falls at the beginning of the loop, we stopped. So we check this at the beginning of each step of the loop. Right, so we can shorten this and just print out these values, right? I is 0, 1, 2, 3, and 4. So one way to think of this, which will sound very familiar if you're taking Python, is that when you see this format, int I is equal to 0, I is less than some number, it will print out all the numbers from 0 up to but not including this number. So this printed out all the numbers from 0 up to but not including 5. So if I change it to this, or I change I is equal to 3, what numbers is this going to print out? 3, 4. 3, 4. 3, 4. Up, it's going to start here and go up to but not include this number. Right? Any suggestions on how to get it to include 5? Yep, less than or equal to. So, but we know in this format, though, if we start from 0, it's going to print exactly this amount of times. Specifically, it's going to print this minus this number of times. Now, we can put any kind of anything we want in here, mind you. We can print, we can do 0, 1, 2, 3, 4. Right? This goes up by 1. But if I wanted it to increment by 2, we can do... So now this will change i's value by 2. This statement over here, this is shorthand again for I is equal to I plus 2, which means we take the current value of I, add 2 to it, and store it in I. Right? Remember, this this over here is not the equal sign. It's the equal sign, right? It looks like it. I keep saying equals, but what it actually is the assignment operator, where basically it takes these values on the right and stores it on the left. So it takes 0, adds 2 to it, then stores it in I, which value gets updated to 2. Then it takes that value, adds 2 to it, so it updates it to 4. So we just print out 0, 2, and 4 in this case. Make sense to everybody? So for loops are pretty powerful tools for us. So let's go ahead and see what we can do with them. You know, we can use them again in our kind of our ASCII art to do stuff, right? Let's see. We can do. What can we do over here? So I'm going to move this over to another loop called another function called public static void loop example, so that we can call it later and run it. Okay, so let's see what we can do, some basic stuff. So again, for int I is equal to 0, I is less than, let's say, 10, system.out.println dot. Oh, what am I missing? I'm missing a semicolon. All right, so prints out 10 dots. All right. So if everybody feels like they've got a pretty good grasp of for loops, right? You put whatever condition you want in here, right? And typically we use these to count. One fun thing that we can do is that we can use it to like do some mathematical stuff. So we can print out like maybe, so let's see, we can print out some like multiplication stuff. So here's 1 through 10. So, or sorry, the value 0 through 9, right? And then we can add a tabbed character right over here. So this gives us a tab plus I times 2 plus, then we can do another tab to do an plus I times 3, right? So here's 0, then here's I multiplied by 2, then here's I multiplied by 3, right? So 3, 6, 9, 4, 8, 12. So you can give different so you can print out different values like that. You can modify them. Let's write a for loop that basically prints all the prints the squares of a bunch of numbers. Like, let's actually write that into a method. Public static void print squares. Right? What is the square of a number? Right? And square of a number is it times itself. So right, 2 squared is 4, 5 squared is 5 times 5, which is 25. Right? Any more than that, of course, is, you know, I mean, I've got them memorized simply because I do them so much, but I mean, beyond that, really, it's fine. So let's print out the first 10 squared numbers. So for int I is equal to, I want to do 1 through 10 because 0 squared isn't that interesting, right? So let's go 1 up to, how do I include 10? I is less than or equal to 10. If I want to include 10 in it, right? So this is 10 different numbers in total, right?
Wait. We can write multiple public tag void.
Yes.
It's showing up as an error for mine.
They have to be inside of the class, not inside of main. Okay. So for int I is equal to 1, I is less than 10, I plus plus. So there's less than or equal. So here we've got 10 different values, right? 1 through up to and including 10. If I didn't go up to 10, right, this would be what values? 1 through what? 9. So that's how many distinct values? 1 through 9 inclusive. So it's not 1 through 10, it's 1 through 9, which is 9 different values, right? Now, this is how many different values? This is 0 through 9, or 0 through 10, but not including 10. That's 10 different values, right? So, and this is 10 values as well, okay? So let's just go ahead and print out just the values of I, just to make sure that we're not crazy. Print line, I. And this is actually not going to do anything. It's going to print out what we had here. What's going on? I created a command, but I never called it, right? Program always does what I tell it to do. So let's go ahead and call the command. Print squares. Boom.
Wait, I didn't see it.
See here? In main, I wrote print squares.
Wait, but I mean the expectation. I'm trying to figure out how to write it. The for loop, I did.
It's right here on top.
No, I mean the one for printing squares.
It's right there. It's on the board. It's highlighted. It's not finished yet, so I was just making sure it works. All it does is print out 0 through 10, 1 through 10. Okay? So instead, we want to print 1 squared through 10 squared, right? So let's go ahead and say, let's go ahead and turn this into text. So I plus squared is plus so how do I do squared in Java? Well, not an easy operation. I can just do I. If anything's squared, I can just do I times I, right? That's pretty easy. There's another way to do it, but there's no need to introduce it. So yet. So now I can say I, which is the value. So right, I squared is I times I, right? So in the first iteration of, so how does this work? We start out with I is equal to 1. So if we systemed out that print line, 1 plus squared is plus I times I. So so 1 squared is 1 times 1, which is 1. Then we update it to 2, and then we run the loop again, because 2 is less than or equal to 10. So now 2 plus squared is 2 times 2, which is 4. Then we update it to 3, then we update it to 4, 5, 6, 7, 8, 9. Then we get to 10, right? And we do 10 squared is 10 times 10, which is 100. And then finally we update it to 11, right? And so once it's 11, it's no longer working. Oh, sorry, it's false. Once I is equal to 11, it's false. All right. Everybody feels like they got a pretty good grasp of for loops?
I'm trying to write that it's not working for me. It says there's an error.
What? Did you read the error? What does it say?
No, it doesn't.
So, so everybody who nodded wrong, you have no grasp of for loops yet because I haven't tortured you enough yet. So, because it's about to get a bit more fun. So let's go ahead and do something a bit fun here. All right. All right. So, public static void print rows. And this will probably be, and something like this will probably be what obsesses you for about the next week in my class. All right. All right. So this is going to be this example is going to teach. So this method will teach possibly more than one method teaches in the entire class. Sorry, the most one method teaches in the entire class. So let's go ahead and get to it. So for int I is equal to 5, I is equal to, let's go with, yeah. Let's go with 1 up to and including 5. So the numbers 1 through 5, okay? I's values are 1 through 5. Everybody's clear on that, right? Everybody's clear on the values that I in print rows is 1 through 5, right? All right, let's keep on. For int j, so this loop is inside. This for loop is inside the other for loop. Int j is equal to 0. J is less than I, j plus plus, and now be sure you put j plus plus there as opposed to I plus plus. Done that a lot of times. I make that mistake. It ends up getting yourself into what's called an infinite loop, which is a nasty situation to be in. So this will be a lot to unpack. Sout, system.println. Let's do star here because those are nice and distinctive. And instead of doing a print line, this should be a print line, and leave a blank for the print line. So any idea what this is going to print out when I run it? No clue. That's perfectly okay because we're going to have to digest it. Okay, print rows, run it. It prints out 1 star on the first line, 2 stars on the second line, 3 stars on the third line, 4 stars, and then 5 stars. So this is what we call a nested for loop. Now this one's actually not so bad to digest, right? What are I's values? 1 through 5, right? Right? So each time this outer loop runs, we run the inner loop. So the inner loop runs, right? It says j is equal to 0, j is less than I. Well, what's I's value? What are the different values? Well, or rather, what are the values of I? 1, 2, 3, 4, and 5. So first time we do the outer loop, I's value is 1. So we run this line once, right? Because this is the kata, right? This is int j is equal to 0. J is less than a number. Start from 0, go up to, but don't include this number. So print 1, then 2, then 3, then 4, then 5. So this prints out a grand total of 1, 2, then 3, then 4, then 5 stars. All right. So let's go ahead and break it down. I find that the easiest way to do this is to break it down using, and I'll capture this on the whiteboard. So give me 1 second because I'll need to remember to change it back to, okay. So I find the easiest way when you're confused by for loop is to actually just work through it like you're the compiler of the computer and actually write it down. So let's start with our variables. We've got a box holding I's value, and we've got a box holding J's value, right, and then we've got our output over here, okay? So for int I is equal to 0. Sorry, for int I is equal to 1, right? So I starts out as 1. Okay, is 1 less than 5? Yes, it is. So we go soaring into the loop. Okay, so now we start here. For int j is equal to 0. We set j is equal to 0. Is j less than I? Yes, it is. So we go into this. So we go into the loop. System.print star. Okay. We finish that iteration of the loop. We increment. So now that we're done at this, now that we're over here, that means we run the update statement, right? Which means we increment j to 1. So now we check the loop's precondition. Is j less than I? Is 1 less than 1? No, it's not. So we're done with this loop. So we go on to the next line, right? We're done with this. We're done with the inner loop. So now let's go on to the next line. It says system.print line, which means that I go from here to the next line, right? I make room to make the next line. Yes.
Does it add a blank line, or does
Yeah, it just
go
adds
to the next line?
It prints out a new line state. It adds the /n character.
Okay.
Which ends up being kind of the same thing from the user's perspective. Okay, so now that this for loop is over, by the way, the inner for loop is over, j has no value because it doesn't exist right now. So we get to the end of this loop, we increment I to 2. Okay, and this will be tedious for the first 4 bit, and then I'll speed up the iterations. Okay, I is 2. Now we enter the inner for loop. J is 0. Okay, is 0 less than I? Is 0 less than 2? Yes, it is. So we print out. So we run the block of code inside. We print out a star. We increment j to 1. We check it against the inner loop's precondition. Is 1 less than 2? Yes, it is. So we print out a star. We increment 2 to 2. So we increment j to 2. Is 2 less than 2? No, it's not. So we're done with the inner loop. Then we print out a new line. That's why I'll start as a new line when we get to this again. Okay? All right, notice that we have a print here and a print line over here. Okay? So now we go ahead and increment. So now we're done here. We increment I to 3. Okay? So for int I is equal to, so let's go ahead. Let's see. So we go into the inner loop. We set j is equal to 0. Okay? We print, so is 0 less than 3? Yes. So we print a star. Increment j by 1. Is 1 less than 3? Yes. Is 2 less than 3? Yes, it is. So now is 3 less than 3? No. So we increment I to 4. Sorry, so we print a new line, we increment I to 4, we go into the inner loop again. Is 0 less than 4? Yes. Is we increment this one, is 1 less than 4? Yes, it is. So update it. Is 2 less than 4? Yes, it is. So update it. Is 3 less than 4? Yes, it is. Right? Everybody see how this works now? Kind of? All right. So now let's go ahead and try this out. So we've got 1, then 2, then 3, then 4, then 5. All right? Okay. So let's get, all right, so if that wasn't nasty enough, let's go ahead and try to puzzle out what I'm going to do right now. Okay? Print descending rows, which kind of the name should give it away, but let's go ahead and see. 5. All right. So now I've got 5 is, int I is equal to 5. I is greater than or equal to 1. I minus minus. What are the conditions? So what are the values of I? 2 and 1. 5, 4, 3, and 2 and 1. Right? Makes sense there? They're going to be 5, 4, 3, 2, 1. So just what we had, but in reverse. Oh, let me print descending rows. So 5, 4, 3, 2, and 1. Right? 5, 4, 3, 2, 1 rather than 1, 2, 3, 4, 5. Right? We had 1. 1 is less than or equal to 5 there. Right? Now I've got 5. 5. Oh, 1 is, sorry, I is greater than or equal to 1. And now I minus minus. Any idea what would happen if I did this? Instead, where I did int I is equal to 5, I is greater than or equal to 1, I plus plus. Any idea what happens there? Sorry? so that I is greater than 1, so I print it out, add 1 to it. I is greater than 1, so I print it out and add 1 to it. And I keep doing that, right? It's always true. So I keep doing it. Although, interestingly enough, it's not actually going to run forever. Believe it or not, it will not run forever. Let me go ahead and squelch the print line statement because it takes a lot of time to print it. Right? It's going to run and says it finished. How did it finish? Right? It's always going to grow. Let's go ahead and add an if statement just to see. Well, it's always going to be bigger than 0, right? So if I is, let's go ahead and say if I, let's just say if I is, actually that's not going to work. So why don't we make sure that I exists outside of this for loop just to make sure. So int I, right, now I'm going to make it exist outside of the for loop. Okay, int I is equal to, so now I'm going to remove the int over here. I is equal to 5, right? See, everybody see how now I exists outside the for loop now? So I'm going to print I out. Oh, well that's weird. Negative something something 2 billion, right? What happened there? Well, Python isn't like Java. Java isn't like Python where it handles numbers for you. These numbers are 32 bits. Okay. 32. Oh, right. Sorry, I wasn't capturing this on. I even put a reminder on my finger so that I would switch it over. Okay, so here's that code. Right, here's the descending code. So, all right. So let me go ahead and once again just put this down here. Okay, so now let's go ahead and just, so 32-bit numbers means that basically we use a bunch of zeros and ones, 32 of them precisely, right? We have, and the way it works is that we have 1 0 over here to indicate the negative or positive sign, and then we have 31 of these suckers over here to indicate the actual value, okay? So 31 over here. So rather than working with big numbers that are 32-bit, let's just work with 4-bit numbers, which are fairly straightforward. Okay, so right, we've got so this is 0. Okay, this is 1. Right, this is the ones place, and in binary this is 2. Why is this 2? Because this is 2 to the 0th power, 2 to the 1st power, 2 to the 2nd power, and 2 to the 3rd power, much like in decimal how this is 10 to the 0th power, 10 to the 1st power, 10 to the 2nd power, and 10 to the 3rd power, right? Right, this is the ones place, the tens place, the hundreds place, and the thousands place, right? So this is the ones place, the twos place, the fours place, and the eights place. That make sense at all? Although, actually, technically, we're not going to, because we're in binary, we're not going to use this as the 8th place. We're going to use this for positive or negative. Okay? So, we're going to go ahead and, so 3 would be 2 plus 1. So, this is 3. Now, in decimal, this would be 10 plus 1, which is 11. Right? But this is 2 plus 1. This is 4 plus 0 plus 0. So this is 4, right, and so on and so forth. Now, the way negative numbers work in Python, in Java, actually, well, in binary, is very interesting. It's something called 2's complement, something that I'm just going to explain here so you understand why what's going on the computer. It's actually a very interesting thing. 2's complement, in order to do a negative number, right, you'd think that basically, okay, so this is negative 4. And if this is 4, if this is the positive negative sign, then this should be negative 4, right? But this makes it actually very hard for your computer to do any kind of math with it, right? These should, if I add these things together, positive 4 and negative 4, the result should be 0. But if I add them together, well, let's go ahead and show you. Binary addition is so easy, okay? Okay, 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 1 is 0, carry the 1, right? Just like 5 plus 5 is 0, carry the right? Right? 1 plus 1 is 0, carry the 1 because it resulted in 2. 2 is 1, 0, so it's 1 carry. So 1, 1. So we ended up with a out of bounds number over there, or a number with that. So it does kind of work like that. Let's look at, so that works for that one. Let's look at adding 3 together. 3 and negative 3. 1, 0, 1, 1. So that's negative 3 and positive 3. Let's add those together. 1 plus 1 is 0, carry the 1. 1 plus 1 plus 1 is 11, but there's 1, carry the 1. Put a 1 over here. So that says that 3 plus negative 3 is negative 4 plus 2, which is 6. So that's not going to work. So there was a bunch of fiddling about, and they actually figured out a way to do this, which is called 2's complement, which is that if I want to figure out what the negative of a number is, I get the bitwise complement, which means I flip the bits, okay, and then I add 1 to it. So negative 3, in fact, it's actually pretty easy to figure out. I flip the bits, so 1, 1, 0, 0, and then I add 1 to it. And the reason for adding 1 to it is so that so negative 0 ends up being 0. Because if for negative 0, we flip all the bits to a bunch of 1s, and then we add 1 to it. So this is negative 3. And adding this to 3, what this does is 1 plus 1 is 0. Carry the 1. 1 plus 1 is 0, 0, 0. And then this 1 gets thrown out over here, right? We don't have room for it anymore. This is what we call kind of an overflow. Okay? Where the value just kind of we had, and that's actually a feature when you kind of do, when you do math like this. So actually, now you can do the reverse too by adding negative numbers by subtracting. Subtracting is just adding negative numbers. So how many of you have played Civilization, any of the Civilization games? Sid Meier's Civilization. Okay. So have you ever noticed that Gandhi is a nuking madman in the late game?
Got like 2 hours on it.
Got like 2 hours. Okay. So interestingly enough, so let me explain. So Gandhi, as you all well know, is like known for the opposite of nuking people, right? Right? He's kind of like essentially is the icon of peace in basically world culture. Okay, so when Civilization 2 came out, this was the case, right? They programmed basically in Civilization games you play as the leader of one of the world civilizations and try to bring it from the prehistoric era to the modern era, right? And you build up technology and all stuff, and you adopt new forms of government. So the AI for Gandhi was made to be very peaceful, right? Right, so his aggression was set to 0. Right, they had an 8-bit value for the aggression, which means you had 8 zeros. Okay? So you had an 8-bit value. So furthermore, these were what we call unsigned bits, meaning that basically that they didn't bother using this one for a positive or a negative. Okay? It was just the values from 0 to 255. Okay? So Gandhi had an aggression value of 0. So what would happen, though, is that come the modern age, Gandhi would adopt democracy and then start producing tanks like a madman and threatening you with nuclear weapons. Okay, and so they looked at the game and they found out, well, wait a second, when the AI adopts democracy, what happens is that they subtract 1 from the AI's aggression score, which wrapped it around to 255. So as soon as he became as a result, a programming error gives him an aggression in the modern era of 255 out of 10. So he starts that was kind of so they kind of kept that feature on as an Easter egg in future Civilization games. But that's just a handy story for remembering what happens here. So as a result, right, going back to our code over here, okay, we have, let's make sure I changed, yep. So for our code over here, we have all these different values that are printing out, right? And at the end, we got to negative 2,147,000,000. Okay? Now, why does that print out? Well, because we went all the way up to the positive numbers, and then we added 1 to it, so it wrapped around to the negative numbers, right? It added 1 so it was looking like this, right? We had a bunch of, right? We had, just imagine there's 31 of these instead of 7. We added 1 to these, it became 1 0 0 0 0 0 0, which, and imagine again there's 37, there's 31 zeros, right? So this became negative, the biggest number there was. So that's why that one is there. So now, that's just an example of a loop. So let's go and change this back to the form that we have it. So int okay, so 5 4 3 2 1. Right? Those are our statements. Whoops. So now if we take the body of this other for loop that we hid in there and throw it in there, let's go ahead. Inner loop says j is equal to 0, j is less than I, just plus plus. So remember, i's values are 5, then 4, then 3, then 2, then 1. So what should we expect to be printed here? How many stars on the first row? 5, right? Because I starts at 5. Then what happens to I? We did subtract from I. And then this will print how many after we've subtracted 1 from I? So before 5 becomes 4. 4 stars. Then 3, then 2, then 1. So this allows us to do kind of very interesting things. Like this. That's okay, so 5. Int j is equal to, so we can reuse j because we're outside of the for loop for there. J is 5. J is greater than I. J plus plus. Sout. This is about the print dash. And let's see what happens here. Oh, infinite loop. Terminate. That's right. You see, I just accidentally created an infinite loop there. How did I create an infinite loop there? Anyone? The j plus plus. J is equal to 5. J is greater than I. J plus plus. So let's go ahead and kill my, and I think it's locked me out of my IDE, so what do I have to do? Go open this up. Oh, I can hear those fans going. End task. There we go. Now we open it back up. See, it even happens to me. So once I fix that error, I'm going to give you guys a break. Okay? Let's try j minus minus. Now run it. That's pretty nifty. I've got stars, then I've got dashes. Okay, so we'll analyze this in about 5 minutes after you guys get back from a break. Then I'm going to adjust this, and then I'm going to give you time to work on the Pope problem and the latest homework. All right?